A farmer has 2,000 yards of fencing to enclose a rectangular pasture. Here's our pasture, and our first question is, what will be the perimeter of the pasture? Well, the perimeter of the pasture, the distance around the pasture, will equal 2,000 yards. All the fencing will be used to enclose the pasture. B. We also know this. Perimeter equals 2x plus 2y. 2x's, 2y's, add them up. The total perimeter equates to 2x plus 2y. Our task is to solve for y. So we'll isolate the term with y in it. So subtracting 2x from both sides, we have 2y equals p minus 2x. Our next task is to isolate y, so we'll divide both sides by 2. 2's divide out, and y equals p minus 2x over 2. Part C asks us to express the area as a function of x, where x is the length of the rectangle. So area equals, the area of the rectangle equals xy, and y, right now y equals p minus 2x over 2. We need to replace p with 2,000 so we can write y as a function of x. So y as a function of x equals 1,000, or excuse me, 2,000 minus 2x over 2. So we can factor a 2 out of each term, and we get 2 times 1,000 minus x divided by 2, and the 2's divide out, and now we have y as a function of x, and that is y equals 1,000 minus x. Now we can write the area as a function of x, because we can replace y with 1,000 minus x, and we have x times y, which is 1,000 minus x. And I'm going to write this two ways. I'm going to write it in factored form, and if we multiply through by x, we'll have 1,000x minus x squared. Part D asks that we find the value of x that maximizes the area of the rectangle. So there's several ways to do this. First, let's use the graphing method. And we know just by inspection that this is a quadratic equation. Furthermore, we know that it opens down. The parabola opens down because the coefficient on x squared is negative. So let's make an approximate graph of this equation. And the zeros are 0, because 0 will take this to 0. Also, if x is 1,000, we'll also get a value of 0 for the area. Now, the axis of symmetry lies exactly between the two zeros of a quadratic equation. So halfway between the two zeros. So then the axis of symmetry lies at 500. So then 500 is the x-coordinate of the vertex of this parabola. It's the value of x that will maximize the area of the parabola. Now there's another way to find this value, and that is this. Consider the quadratic equation. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. The axis of symmetry corresponds to x equals minus b over 2a. That is the axis of symmetry for any quadratic equation. So let's replace a and b with the appropriate values. X equals, and b in this case is 1,000, and a is -1. The coefficient on x squared is -1 over -2, and notice x then equals 500, which is the axis of symmetry. And we've found the value of x now that maximizes the area, and we've done that in a couple of ways. Our remaining objective is to find the maximum area. So we'll evaluate a of 500. And using this equation, the top equation, we'll replace x with 500. And notice, if we replace x here with 500, 1,000 minus 500 is 500. And the product of these two is, well, 5 times 5 is 25, and we have 1, 2, 3, 4 zeros. So there's our 4 zeros. And consequently, our units are yards, so these are going to be 250,000 square yards. 250,000. And we are done.